Hello, welcome to this video. In this video, you'll be looking at travel graph in mathematics where you are taught to find the speed of the car at a certain given time, which is not here. So the question says, the diagram below is a speed time graph of a car. The car starts from rest and accelerates uniformly at 2 meters per second square. So we have acceleration as 2 meters per second squared. That's our acceleration. Until it reaches a speed of, and we have velocity, which is 16 meters per second. It then travels 16 meters for 40 seconds, and after which it comes to rest in further 10 seconds. So it starts from rest, that is 0, and it accelerates uniformly for this time of not given. Then it maintains the same speed, which is 16 meters per second, for further 40 seconds. So for us to know this time here, we need first to know this time here. That's when we'll also be able to know this time here. So we have these, we need to find the value of t, the time here. Now this time is accompanied by acceleration. Now, so I'll put it here. Know that acceleration is equal to final velocity minus initial velocity over time taken. Acceleration here we have is 2 meters per second squared, which is equal to velocity. In this case, the final velocity is 16 meters per second minus 0 meters per second divided by the time taken is what we're looking for, which is t minus 0, which is t minus 0, which is just the same as t. So here we have 2 meters per second, which is equal to 16 over what? Over t. Now when you look at this, when you cross multiply, there, going to have 2t is equal to 16. Then I'm going to have 2, going to have 2. Then you see that t is equal to 8 seconds. There, done. Then find the distance traveled in the last 50 seconds. Now know that this is 80. All right. Now that's saying there's 40. Where there's 40 here. So that would be 40 plus 8 here. Here it would be 48. Then 48 plus 10 here to be 58. So in the last 50 seconds, we're talking of this part. Okay, so when you talk of the last 50 seconds, we're talking of starting from 8, because our graph is like this, right? Where there's a 0 here, then it's like this. So when you look at this, from here to up to 58, when you find the difference between 58 and 8, it gives you 50 seconds, right? Not just this part. The last 50 seconds, it means you need to get 2 times and find the difference so that it can give you 50, which is 58 here and 8. So the last 50 seconds start from here up to this side, like I did. Now, how can we solve this? Now this is a trapezium. Area of the trapezium is equal to half a plus b times what? H. In this case, our h is our velocity. Remember this side there's a velocity. There's a velocity side, which is 16. Okay, so we are saying half a is the smallest distance, that is from 8 to 48. The difference will give you 40, plus b is the longest distance from 8 to 58, that will give you 50. Then h is 16. So a is equal to 48 minus 8, which is 40. While b is equal to 58 minus 8, which will give you 50. And h is equal to 16. Then we have 90 here, divided by 2 times what? 16. Well, this will be 45 times 16, 2 into 90 is 45. We're now saying 45 times 16 to give you 720 meters. Let's look at part C. The last part which I'm interested in, it says find the speed at t is equal to 53. Now I have drawn something like this to help you. Now the first step that you need to know to find, so I just approximated that. Let's say 53. Remember this graph is coming from that side, from that side, so that you know I just got paropi. We assume that this is 53 and the speed that we're looking for is somewhere there, because this is 0 and that speed and the final speed, which is 16 meters per second. Now this side, the slope is going down, so we need to find the negative acceleration, which is also known as the retardation or deceleration. So deceleration will be equal to that over that, and we need to find 0 minus 16 over time taken. Now it will be, I'm not considering this. I want to know the entire acceleration in this area. So that will be 58 minus 48. This will give me negative 16 over 10 to give me negative 1.6 meters per second squared. That's the deceleration that I have. Step 2. After knowing the deceleration, now I can find velocity. From first law of motion, we are saying velocity is equal to at. Right? Velocity is equal to acceleration times time. Now, which is just the same as here. Now, velocity in this case will be acceleration. We have it's negative 1.6 meters per second squared times the time. Now, the time we are going to get here is the difference between 53 and 48. This will be negative 1.6 squared times 5. Velocity here, it will be negative 8 meters per second. Why are we getting negative 8? Because we took acceleration as negative. Therefore, the velocity is 8 meters per second. Those are the only two steps involved. Know the entire acceleration or that part, then you can find velocity by finding the difference in 2 times. You're welcome. I'll see you in the next video. I'm PVS the tutor.